Hey.
Hi, everybody.
Hey, it actually works.
Cool. All right, welcome to the Wi-Fi light switch assembly stream.
Hi, my name's David.
And I'm Spencer.
And then today, like Spencer said, we'll be building the Wi-Fi light switch, which is inside of this box, kit number 4, designed by Spencer, who will be assembling it. We'll be answering any questions that you have in the box to pass Spencer. Yep. Yeah, and the questions don't have to be about this kit specifically. We have all the past kits. So, yeah, really any Thimble related questions we'll take.
Cool. All right, so let's get started. So, I'm going to switch to the other camera. So the first step we're going to do, we're going to start with the electrical assembly of the Wi-Fi light switch kit. So make sure you've got all your tools set up. You've got your soldering iron, you're going to need a screwdriver, and your solder. So inside the kit, we've got our lovely postcard and our Thimble stickers. And what we're going to get out now, we're going to grab the PCB, and we're going to grab a small bag of electronics. That's all we'll need for now. So set this aside.
Okay. Okay, so we're going to take the PCB out of its little baggie. We can leave the... Okay, we can take out the headers too. And all of the components. I'll take the trash. Always want to keep a clean workstation.
So one of the things you want to do, just to double check, is make sure that you have all of your pieces. And you can pull up the learning website alongside this stream. Go ahead and see all the beautiful photos and instructions we took for the Wi-Fi light switch kit.
Who took those photos?
I took those photos.
They're beautiful photos.
Just go ahead and quickly line these all up here just to make sure we've got everything.
Don't know exactly where to put us.
It's good.
You keep moving stuff. Okay, so components laid out, PCB ready. We have our instructions. What's the first instruction?
All right, so first thing we're going to do is we're going to grab our two 10K resistors.
What do those look like?
Those look like this. They have a brown, black, and orange band.
Okay.
And those will go down here in the bottom left of your PCB. And the rectangle's labeled 10K.
Now, do I have to put these in any special way? They
Nope.
have to... No?
So resistors are not polar, and they can go in either direction. So it doesn't really matter which way you line them up. They could go in two separate ways, or they could go in the same way, whichever you like better.
And when you say ways, you're just talking about the pattern of colors on them.
Yep. So you can see here on mine, I've put one of them with a gold stripe on the left and one of them with a gold stripe on the right. Doesn't matter. They both work exactly the same.
Okay, sounds good.
So now that we've got our resistors in, we'll go ahead and bend the leads a little bit to keep them in place. We'll grab our soldering iron here and our solder.
Now, if you don't know how to solder, you can go to our YouTube channel, youtube.com/ThimbleIO, and you can solder, by the way. And you can look at a new how to solder video featuring myself. It's a bit more in depth and it has a couple more macro shots and it goes through a little bit of troubleshooting and how to clean up bad solder joints and stuff. So you should check that out. If you don't know how to solder or if you just need a refresher, go for it.
I guess what we forgot, I need those side cutters.
It's a good thing we have a Thimble toolkit. I'll go get that.
So I'm just holding the soldering iron here against the pads for a couple seconds, and I'm feeding the solder in. You can see it melts down in. Thanks. So now we've got our 4 solder joints on the bottom of our 10K resistors. Now we've got all the solder joints done. You can flip it over and see that the resistors are nicely held in place and they don't go anywhere. So now that we've got our side cutters from our Thimble toolkit, go ahead and clip these leads, and I'm going to hold on to the leads with one hand, clip them with the other, That way they don't go flying.
Perhaps onto the carpet. Okay, cool. First step done. Looks nice. All right, second step.
Now we're going to take the diode, and this is different than the resistors, and that the diode has a direction. So there's a black line here on the left side of the diode. It's a little small, but it's right here on the left side. And there's also a line on the PCB right here in the rectangle marked D1. So if you're on the learning website, you can see a close-up picture of the PCB and the diode lined up, but you're going to make sure that the black line is facing towards the left side of the PCB. So the black line on the diode should line up with the line on your PCB. So go ahead and bend the leads the same way that we did for the resistor. We'll put that in here, the rectangle marked D1. So here you can see the black line on the left side matches with the black line on the PCB, and the photo down here.
It's a pretty bad photo. For the stream? For the stream. It's a beautiful photo normally.
Feel free to go ahead and check out the learning website for the light switch kit. You can look at a larger version of the photos and see text that goes along with all these as well.
So, black stripe to the left.
Yep.
And that matters because diodes are polar. But if you do mess up, you can just unsolder it, flip it around, put it right back in.
All right, so now that we've got our diode in, do the same thing with our soldering iron and our solder here. We'll put the tip down for just a couple seconds to heat it up, and you should be able to push the solder right in.
All things that can be learned in the How to Solder video available at youtube.com/Thimble.io.
And they're free.
And they're free. You don't even have to be a subscriber.
All right, so we've got our two solder joints done for the diode. We'll do the same thing by holding on to the leads and clipping them. All right, now, step 3 is the reset button.
Now there are 2 buttons included in the little parts baggie that Spencer has laid out on the top of his workspace.
That's correct. So the smaller button here is the Arduino reset button, and that goes down here in the spot labeled switch 1. The larger button is for a later step. We'll get to that after.
Okay, so small button, bottom left of the PCB.
So if you'll notice on the button, you can see that there's 4 legs, and they come out of the top and bottom in this case. And the holes on the PCB are slightly longer this way than they are left and right. So you can only put the button in one way, and that's with the 2 legs on top and 2 legs on bottom. It won't fit turn 90 degrees, so make sure when you line it up, it goes in. And all you have to do is push it right into the PCB, and the legs will grip on once they go through.
Now, other than putting the button with the correct, up and down orientation, can I flip that 180 degrees and put that in?
Yep, so the button works as long as both legs are on the top and bottom. The pinout is exactly the same for that.
Okay, sounds good.
So now that that's in, got our 4 legs sticking through, and they're all sticking up through the back, and none of them are bent on the front of the PCB. Grab our soldering iron, touch it down to the leg, feed our solder in. And you should see, you don't have to use a whole lot of solder because these pins are small, and if you add too much, then you can go ahead and get your solder wick or your solder sucker and remove the extra solder. Out of the 3rd leg here. If you notice your solder not quite sticking, or it's being pulled back by your soldering iron, it's because you're not holding your soldering iron onto the pin long enough to warm it up. All things you can learn in the How to Solder video on youtube.com/Thimble.
Thimble.io.
All right, We don't have to clip leads for the button because they're short enough that they don't stick through any further than the solder. So now we're done with that. We'll go to the next step.
Okay, and that is the resistor pack.
Yep. So the resistor pack here is different from the resistors we put in earlier, and that this is actually multiple resistors in one little package. They all share the same ground pin, so they can save space. But that means that the pin out of this is not the same as a regular resistor. So the reason we know which way to put it in is there's a little dot here on the resistor pack, and there's a square hole on the PCB here on the right side. So what we want to do is put the dot into the square hole, and that's going to mean that the little letters and text on the resistor pack is going to face up on the PCB.
So away from you.
Away from you. That's correct.
Assuming you have the PCB in the normal, readable orientation.
Yep, so all you want to do is make sure you've lined up your dot here on the right to the square hole in the PCB, and that the text is facing up towards the Thimble logo on your PCB. So once you've got that, you can flip over your PCB, and the legs on this are a little short, but you might be able to bend them a tiny bit. As long as you keep it flat on the table, you should have no problem soldering it in.
Okay. Now, even though all the resistors are together in a pack, you still want to make 4 individual solder joints, right?
Yeah, that's correct. You don't want to connect the pins together because then you'll short your resistors, and that's not good.
Yeah. So, even though they're all together, 4 separate connections, you don't just want to see a big, horizontal line of solder. That's bad.
Yeah, it's the same way with these resistors down here. You're not going to connect the 2 sides of the resistor. So now that you've got your 4 clean solder joints and they're not connected or anything, we can flip our PCB back over and straighten out our resistor pack. It's always good to clean your soldering iron between steps. All right, so now we're going to move on to one set of capacitors. There's 2 different kinds of capacitors included in your kit, and we've also included 2 spare capacitors in case you accidentally solder them in backwards or break one. So the first set here are the 10 microfarad electrolytic capacitors, and those are these black cylindrical ones on the paper tape.
They look like little tin cans.
Yeah. So the way these go together is you can either peel off the side of the tape here.
I usually just rip them out. I'm not very patient.
Or, wow, these ones are in really good.
It's a quality product.
Yeah, so you won't ever use the cardboard again. So you can go ahead and just rip that off. And your resistor should pull out. Wow. There we go.
So your capacitors.
Capacitors, whoops. All right, so now that you've got your capacitor out of the paper, you'll see that one leg is longer than the other one, and that's the positive leg. And so on your PCB, there's the positive hole and the negative hole for your capacitors. Now these capacitors in the kit, there's, like I said, the 2 different kinds. This kind, the electrolytic, are polar, so it does matter which direction you put them into the PCB. So we're going to want to take the long leg here and put it into the square hole on the left. And you'll also notice that these capacitors have like a little white or gray rectangle and like a minus sign on one side. And that's the same side as the shorter leg. That's going to line up with the little white marking on your PCB for the negative hole.
So, to recap, long lead positive, short lead negative, also the side with the gray white rectangle in the negative side. Also another way to tell that that's the negative side.
Yep. So now we're going to line this up, and you'll notice that once you get your resistor, your capacitor capacitor most of the way down, you'll see that there's like a little notch in the legs, and that should fit right into the PCB. So your capacitor will sit just above the layer of the PCB.
And that's fine.
Yep, that's the way it's supposed to be. So take our second one, and that goes up here. So we'll line up the negative leg, the shorter one, on the right in the white hole. push that through.
How's that going?
It may be a little difficult to get past the first notch in the legs of the capacitor, but
If you mess it up, there are spares.
that's why we included the spares. All right, so now you've got your two capacitors in your PCB. There's one up here and one down here. We'll go ahead and flip it over, and then we've got our 4 solder joints. And you want to be extra careful not to connect the 2 legs of the capacitor to each other with solder. So I found that it's easier to put your soldering iron on the outside of the pads, not in between the 2, when you solder it.
And if you did put too much solder and you bridge the connections, if you have a Thimble toolkit, the solder sucker or solder wick, both included, can help you out there. And for more details on how to see that, you can check out the new How to Solder tutorial on the YouTube channel.
So I've just rotated my PCB so that I can continue soldering the outside legs of my capacitors.
It just occurred to me if someone's watching the live stream, they most likely already know how to navigate to the YouTube channel.
Hopefully. But just in case, it's youtube.com/Thimble.io.
There's also a toolkit walkthrough and stand assembly video. We have a toolkit just out of frame right there. Okay, cool.
So I'm looking closely to make sure that my capacitors are soldered correctly and that there's no bridge connections. And they look good. So we'll get our side cutters back again. And I'm holding the legs of the capacitors here. I don't think I mentioned before, but you don't have to put the side cutters all the way down on the PCB and cut. You want to cut just above your little solder peak so that you're leaving a little bit of the lead exposed.
Now, alternatively to holding the leads and cutting them, you could always face the PCB away from you and anybody else and cut them, so if they did fly off, it wouldn't hit anybody. But that's a bit more messy. We're trying to keep it clean.
It's always a good idea to hold on to them. That way you know where they go. Thanks. All right. So now that we've got both of our capacitors soldered in,
One more capacitor.
we have the second kind.
Called ceramic. It is a ceramic capacitor, not electrolytic. And this one is not polar, which means you can put it in one way or the other. It doesn't matter. It's like those 10K resistors we did for our first step. There's only one of these in the kit, and it's like a little beige circle, 2 leads coming out.
Looks like a tiny piece of corn.
I've never heard that before. That one's a new one for me. Yep.
All right, so
But sure.
the ceramic capacitor goes up here next to the electrolytic one on the top. And I've noticed that I made a little bit of a mistake when I put my ceramic capacitor in, and I got some solder.
Electrolytic.
Right. Wow. I got some solder in the holes here where my ceramic capacitor goes. So now is a good time to demonstrate how you use your solder wick to remove extra solder from your PCB. So David's going to quickly run away and grab the solder wick because I forgot to grab that earlier. So we've got our solder wick here from the Thimble toolkit. David also was so kind to grab me a solder sucker. So the correct way to use your solder wick...
What does that look like? What does solder wick look like? I mean, I grabbed it, but I didn't get a good look at it.
It's your braided copper wire in this little, looks almost like a floss container. Shouldn't use it to floss, but
I wouldn't use it to
maybe
floss.
You could. If you're a circuit board and your teeth are solder, then maybe you could use it to floss. All right, so the way you use this is you're going to use the solder wick basically like a sponge. So you're going to get your solder wick rolled out of your floss container. You're going to put it right over top of the solder you want to get rid of. And you're going to put your soldering iron right on top of the solder wick and heat it up and this is going to melt the solder underneath, and it's going to suck it up into the solder wick, just like that.
Just like this, and then right like that. Yeah, because all of these tiny solder really wants to stick to copper, and so when you heat up the solder and get it molten, and you have all these little like high surface area pieces of copper wire all braided together in this kind of mesh, the solder really just wants to flow up there, probably through like capillary action and some sort of weird surface tension type nonsense, and just stick to it. So that's why we use a braided copper mesh wire type thing.
So I flip my PCB over because there's some extra solder on the top here.
Now a solder sucker, which is this, is a bit more, I guess, reusable than solder wick. Solder wick is disposable. So, you know, after you use some and the solder goes in it and you can see the solder in the solder wick, you should probably just cut that off and throw it away. Whereas the solder sucker might not be good for getting really, really little amounts of solder in maybe some weird places, but the solder sucker does a pretty good job of just kind of like taking away a large amount.
Yeah, one thing you want to be careful of is when you're using your solder wick, it's obviously going to get a little warm because it's touching your soldering iron, so don't hold it quite so close to the end, or you might accidentally burn yourself.
Could always use a pair of tweezers or needle nose pliers, or even the diagonal cutters might be able to hold it down if you don't want to use your fingers.
I was never very good at using solder wick, so
I actually been using it. I've been using it to solder those like 44 pin package TQFN things using the soldering iron. So you put like a ton of solder just everywhere, and then you come back with the wick and take it all away, and that leaves you with like pretty decent, not hot air soldered high pin package things. It's ridiculous. It's a waste of time.
Alright, so I wasn't able to get all of the solder out with the solder wick, but now I'm going to try the solder sucker because I like that tool better. Now this is a little bit of a weird way to do it.
Would you like me to hold the PCB?
Yeah, that'd be good. So I'm going to put the solder sucker on one side. I'm going to put my soldering iron on the other.
I always like soldering with a friend.
They don't call them helping hands for nothing. I didn't quite get it. Hold on.
You want to call in a pro? You want to tag me in, coach?
Yeah. Hold it like that. There we go. Oh.
So first you have to prime the solder sucker, which you can see in the new solder video at youtube.com.
Did that work?
You could definitely get a capacitor through this.
All right.
There's no way you can get a capacitor through this. No, just heat it up.
I was gonna say, yeah, you can heat it up.
Don't
try
do
this
this.
at
Don't
home,
do this.
But we're not gonna make you watch me try to use solder wick for the next 2 hours.
Is it heated up?
Yep.
Is your soldering iron in the way?
And then it's only heating up the bottom.
So
There
what
we
we're
go.
doing is called parallel soldering. I mean, it's in enough. Okay.
Yeah.
All right, so after you've placed the ceramic capacitor in, remember, less solder is more. You can always add. It's a bit difficult to take away.
There we go.
Flush with the board.
Yep.
Good job.
All right. So go ahead and finish soldering the leads of this. Any YouTube questions?
We have no YouTube questions.
All right. Because we're so perfect at answering everything.
We've left nothing to question.
the leads again.
Okay. And this is the last capacitor.
Yep. So now we're all set. I'm going to put these spares in a little baggie for later. That way I don't accidentally lose them. And I'm going to put them back in my thimble box. All right, so the next step is our MOSFET, and that's this, not this guy, these guys. So the reason we're using MOSFETs in this kit is
What are MOSFETs?
So MOSFETs are basically a controller that uses a lower voltage to control a higher voltage. MOSFET stands for metal oxide semiconductor field effect transistor.
You better write that down.
You can Google it whenever you want. Nobody's going to ask you. But so MOSFETs work they use a lower voltage to control a higher voltage. So in this case, the ESP for our kit that provides the Wi-Fi access runs on 3.3 volts, but the Arduino that we're using to power it runs on 5 volts. So if we sent 5 volts to the ESP, we risk damaging it. So we're using a MOSFET that's controlled with the 5 volts from the Arduino, but that sends 3.3 volts from our 3.3 volt regulator. So our MOSFETs have our input pin, our source, and then our output, and that's what we use to control our ESP. So go ahead and take these out of the paper here.
Noticeably easier than the capacitors. Okay, so where do they go? What direction? What do I got to do?
So our MOSFETs here, they have a flat side and they have a rounded side. And on the PCB, you can see that there is Q1 and Q2 here on the left. And the silk screen here, the little white markings, have a circle side and a flat side. So we're going to line up the flat side of our MOSFETs to the flat side of our silk screen on the PCB.
Makes sense.
So go ahead and put this one in Q1. And this one in Q2. Just like that. So the flat sides are going to be facing down to line up with the flat silk screen. Let's go ahead and bend these leads a little bit to keep them in place. Grab our solder. Just like always, we don't actually want to connect the pins to each other. Just make sure that they're soldered onto the PCB. So I'm just rotating the PCB to make it easier to solder these in. Whatever's easiest for you. I've tried to hold the PCB in the same orientation for the video for you guys, so it's easier to tell where everything is, but whichever way is easier for you to solder works just fine.
Yes.
So now we'll grab our side cutters and we'll cut these leads off, making sure we leave a little bit of space between where we cut and the PCB so we don't cut the solder away. Alright, so we've got all those 6 solder joints done. Now the next thing we're going to do is the voltage regulator that I mentioned earlier. So this takes the 5 volts from the Arduino and steps it down to 3.3 for the ESP. And that's what we send to the MOSFETs and then to the ESP. So for this guy, we've got a big pad here in the bottom right, and then these 3 holes here. But if you notice, the outline of this has it laying down. So we're going to bend the leads of the 3.3 volt regulator 90 degrees, and you can see a photo of that on the learning module. So you can either, for me it works just fine to use the table.
You could also use the corner of a
bend
table.
it like that. You can stick it in your PCB and bend it. I don't really recommend that. Or you could take some pliers and grab onto there and then bend it down.
Now,
all that you really want is to make sure that it's bent 9 degrees or so, like this.
Now you want to make sure that you bend it. So if you look at the 3.3 volt regulator, you have this kind of black package part and then a silver part. And then on the back, because this is the front. On the back, you have less black package and more silver part. That's the back of the voltage regulator, and you want to bend the leads towards the back. So from the front towards the back.
Yep. And that's to allow that the voltage regulators sit flat, and it also helps to dissipate some of the heat into the PCB. So now that we've got our voltage regulator pins bent, we're going to put it into the PCB here in the bottom right. We're going to push it all the way down and make sure that when you've bent it, that the voltage regulator lines up with the silk screen on the PCB, and that it doesn't, this tab here doesn't cover the pins on the bottom of your PCB, so that there's a little bit of space here, because we're going to put our pins here for the Arduino.
Okay.
So now we've got that in. Solder these, and these are probably the easiest soldering things you'll do on this kit, because they have big wide pads, and you're going to want to add a lot of solder to make sure that they're nice and connected.
Yeah.
Just not to each other.
So you tend to see bigger pads and bigger wires and bigger traces when you're dealing with things specifically that have to do with power. So for small signal things like the MOSFETs or resistors, diodes, or the reset button, you're dealing with, kind of small leads and small traces. But because the voltage regulator specifically only does, voltage and power, it's a little bit bigger. So that way more current is allowed to flow safely. But that's also why it needs the heatsink.
All right, so we've got our 3 pins here, and I'm just making sure that the solder is connected on both sides. It's all melted to the pins there. And we're going to take the side cutters here, and these pins are going to be a little more difficult. You're going to want to probably cut them a little bit higher off the PCB than the other ones, and you're going to definitely want to put your finger over top or your hand, that way when you cut them they don't go flying, because these tend to do that. You should always be wearing safety glasses too. Dave and I both have not so great vision, so we have semi-safety glasses. It's not really the best thing ever, but it's
to keep out flying pieces, it's good enough. In elementary school, in shop class, I was just allowed to wear glasses instead of like legitimate safety glasses. I question that now. They were like, oh no, he's got glasses. It's fine. Nothing can hurt his eyes.
All right, so now we've got our MOSFETs in and our voltage regulator in. Now it's time to put in the headers.
So the headers were in the piece. You can go ahead and start cutting them.
So these
safety.
These are in
the big package with the PCB.
Yep. So we're going to need a couple sets of headers for this kit. We're going to need a segment of 8 pins, a segment of 6 pins, and then 2 segments of 3 pins. So we're going to go ahead and just count over. There's little notches in this black strip here. So we'll count 8 down. If you aren't quite sure you've counted the right across, you can line it up with your PCB here, and you should see that there are 8 here that are going to fit into the bottom left. So I'm going to cut right here. And definitely make sure you hold on to both sides of this, because if you cut it and you lose it, we have included extra, but it's always not fun to step on one of these later in the day. So,
especially when they go into carpet and they angle themselves up and it's at night and then you step on them.
Worse than Legos.
Worse than Legos. Or an upturned plug.
Yeah.
Have you ever stepped on an upturned plug?
I don't think I have.
It's painful. Legos are small. You kind of hit the maximum pain threshold pretty quick, but an upturned plug is...
Oh, those are pretty tall, yeah.
Yeah.
All
American plugs.
So we've got our 8-pin one here for the bottom left. Now we're going to cut our 6-pin one. 3, 4, 5, and 6. So that's this one here. And then I'm going to cut 2 3-pin ones for the servo header. That's one set of 3 and a second set of 3. So now you've got these extra here. That's for later. You can use them for other projects, or if you accidentally counted the wrong number and cut it, we've got extra. So I'm going to give this to David. He's going to put that in the bag, put it back in the thimble box for later. All right, so
Where did these go?
there's a...
What am I doing?
All right,
Help.
so the 8-pin one goes here in the bottom left, and if you'll notice, the little holes aren't quite straight across. They're kind of like zigzagged, and that helps to, when you push these headers in, they kind of like grip onto the PCB even though they're not soldered, so that makes it a lot easier to solder them in later.
What a good design, Spencer.
Spent a lot of time making sure that was right. So we got our 8-pin here in the bottom left.
Now, which way are the headers supposed to go?
So the headers should always have the shorter legs here go through the PCB, and the longer ones are going to stick up like this.
So you're at the top of the PCB, and I'm putting the short ones straight down.
Straight down in.
Okay.
So we'll put our 6-pin here in the bottom right. Then we've got our 2 3-pins, and those are going to go here and here, and the spots marked servo 1 and 2.
And that's above and below that very first electrolytic capacitor that we did on the bottom right of the board.
So when you've got them all in, they should all look like this. They should all have the longer sides facing up on your PCB.
Cool, we put them in, we're done, right? That's
it. We have to solder them now.
No, you sure? But they're staying in. Everything's fine. No, you do have to solder them.
Alright, so I'm just going to put my finger here, and I'm going to solder
1, 2, 3.
all of these.
Which, that's going to take a while, so this is a good time for a teaser for the next kit. And all I'm officially allowed to show you is this piece of laser cut, whatever wood this is. Yeah, could go like this. Could go like this. I don't know. It's got a Thimble logo on it. This could be anything.
You guys are gonna just have to wait and see.
Yeah, this is crazy.
So I am making sure that when I've got my headers soldered in, I'm going to solder just 1 pin of these 2 bottom ones to hold them in right now, and I'm going to double check that they're pushed all the way down on my PCB, because this is where the Arduino is going to plug in later, and we want to make sure that these are all lined up together.
Whatever could this be, Spencer? Do you know? I'm not sure I even know.
Good thing we have extra.
Yeah. Good thing that was a very early prototype.
Just going down through all of these headers.
And just like almost every component that I can think of that you'll ever have to do, solder or deal with, each pin is separate. You don't want to make a huge bridge. So Spencer's doing a good job of only using the right amount of solder, keeping them all separate.
They'd fire me if I didn't. Nah, that's a joke. But
It's not a joke.
as an example, let me say I accidentally put way too much solder
Spencer,
on these
that
two
is
first
way
pins.
too much solder. What are you doing?
Oh no! This is when you get your solder sucker.
Prime it. Nice.
So now we can see here in the bottom right that these 2 pins are connected. Can I show really close? Is that even going to work?
Yeah, it's gonna work.
Yes.
Put your hand behind it.
Yeah, like that. So these 2 pins here in the bottom right are connected because I put way too much solder on.
I can't believe you've done this.
So we've got our solder sucker all primed. I'm going to put my soldering iron here and melt all this solder. It's going to take a couple seconds. Then I'll get the solder sucker and I'm going to put the tip right here next to this big old blob. Push the button and it all gets sucked in and disappears, and now you've got 2 perfect solder joints left.
But Spencer, where did it go?
It's inside your solder sucker. It'll be here probably forever until you open it, which I do not recommend doing. Sometimes it comes back out when you reprime it, but
It really is gone forever. Wow.
magical solder learn. They send it back to the factory and they spool it back up into new rolls of solder.
That's true.
All right, so we've got our 8, 6, and our 2 3-pin headers all soldered in. And we'll go back to our instruction here on the learning module. Now the next thing we're going to do is our
Big button.
which I like calling the big button because it's
The bigger one.
the bigger one, and it's much more fun to push. So this one's a little different than the other button in that it has two little black legs sticking down. You can see there's 6 holes in the PCB. So this one's going to go opposite. You're going to put the 2 legs on either side, going to be left and right on your PCB, and that should allow these 2 black legs to go into their 2 holes here where it's marked switch 2. So we'll line this up so that the metal legs are on the left and right, and then it should snap right in and be flat with your PCB. So when you flip it over, you should see these 2 holes here now have the black pegs from your button, and then these 4 on either side have the silver metal legs. So now that that's all set, and this works the same as the other button, that it grips onto the PCB so it's not going to fall out while you're soldering. Let's go ahead and solder these 4 pins in.
Make sure you don't bridge those connections.
If you do bridge a connection, just take us a picture.
And
I
send
want to
it.
see.
I want to see how you bridged a connection on the big button. We joke because the leads are very far away.
We'll send you a new kit if you do.
You know, now we actually have to do that, right?
I'll pay for it.
You're fired. Okay. So we are coming towards the end of the electrical assembly. Coming up on the mechanical assembly, if you've already done it or if you've looked at the learning module, then you'll know that there are 2 types of mechanical assemblies, and by mechanical I mean the part that goes onto the light switch itself.
Hey David, remember those spare capacitors we included in your kit?
Yeah, I do.
Do you know where they are?
Yeah, they're in the box. Why?
Cool.
What happened?
It appears as though I accidentally broke this top one off while we were messing around putting the ceramic capacitor in the top.
Gee willikers.
So, I'm going to grab this extra electrolytic
Capacitor.
These are the
10
microfarad ones. So, that's our broken one. Totally intentional, done for learning. So, I'm going to have to unsolder these 2 little pins here. This is the top one.
Oh boy.
So hopefully, grab my tweezers here. I'm going to unsolder
Sure you want those tweezers?
the 2 legs here.
So while he's going, doing his thing, yeah, so you'll know that there are 2 mechanical assemblies, one for a toggle style light switch and one for a panel style light switch. Today we will be building the toggle style light switch. Of course, that depends on what light switch you'd like to put it on. We're just doing the toggle because we feel like it. And there's also a toggle switch right over there, off shot. So Spencer is doing work on that. I don't know how you did this.
Yeah, I'm not really sure either. But it's a good thing we included extra capacitors.
It's a good thing we're live.
Hopefully, you guys didn't make the same mistake.
I would be impressed.
But it'll give you a little while to catch up to us.
If you are building this along live.
Make sure you've got everything all soldered together. If you do have everything all soldered together, and you haven't broken your capacitor off like me, go grab a snack. Come back in a couple minutes.
You want me to try? You want to switch chairs? I want to give it a try.
I'm not sure.
I haven't soldered anything all day. I'm your co-host.
Sarah did such a good job soldering these in that they're not easy to remove. Okay, so there's one pin.
I guess
Here's the other pin.
I'll distract the audience with another showing.
Okay.
The next kit. Wow. But it's just one piece of wood. How is it bending like this? Well, through the magic of science and technology and 3D modeling.
I don't know if we use 3D modeling for that.
I don't know. Who made this?
So I've got my positive leg in. I'm just using the soldering iron to heat up the solder that's already in the hole so that I can push my capacitor legs through. It's not the official method, but if it works. Do you have any YouTube questions yet?
No. Exhilarating.
It's like watching solder melt.
You proud of that one?
I thought it was pretty good. Oops.
Maybe you want to just pull it forward.
Gotta get this one in.
Oh boy, yeah.
We're almost there. One of the things you can do while you're waiting, if you're waiting, hopefully you're not, if you grab your thimble kit and you take out your acrylic laser cut pieces, you'll notice that they're all covered in paper wrapping. Some people don't like peeling it off because it might be a little bit difficult, but I think it's very satisfying and relaxing. That's one way to put it.
May I have a pair of tweezers?
But yeah, so I'm going to give David a pair of tweezers, and he's going to start peeling that off while I do this. You guys could probably also start doing that.
If you so choose.
The only couple, you only have to peel off the paper from the big piece here, the one that David's holding, and then the force mountain piece, which is that little like curved piece where the bolt will go into later. But all of the circle pieces and that long piece, the extension piece with the two holes in the top and bottom,
You'll
you don't
see
have
it later.
to peel off the paper from those yet.
Or really the spacers. It's really hard to see the paper on the spacers once the whole thing's assembled.
Right, yeah, so you don't have to peel those off. They don't. The only reason the paper is there is when they laser cut the pieces in the factory, the paper is there to keep the acrylic from getting scratched. And
So I'm scratching it now with these tweezers to make up for that. Oh. Alright. Oh, jeez. I'm also making mistakes.
Good. Nobody's perfect, and it provides learning opportunity.
Again, taking off the paper, kind of optional. Won't affect the ability of your kit to switch on or off the lights.
Man, this one's really giving me a hard time.
I mean, are you trying to get it flush with the board?
I'm attempting to get the other one hole through the hole.
I gotta say, peeling off this paper, it's not that bad.
Is it relaxing?
Um,
Not the word you would use?
Not the first word that comes to mind. It's like satisfying. It's got to be a robot that puts on the paper, right? It can't be a person. How do they make acrylic? Well, you see, they melt down all the little solder remnants from the solder sucker, and the ones that don't make it back into the solder rolls turn into acrylic. Or they take the gray out and make it into clear. And then cardboard naturally oxidizes from clear solder.
That's the true part.
So how's that coming? Give us an update.
This is not easy.
Tempted to throw on some music.
Almost done with this, though.
Really? It looks like you're in the exact same place when I started peeling off this paper.
Maybe I am.
Is the other leg in?
One leg's in. having trouble with the negative leg.
Maybe it just needs a little positivity.
Are you proud of that one? That was pretty good, though.
I am. I am really proud of that one. Well, when you want me to take a crack at it, just tag me in. Till then, I'll be peeling off this paper. So I'm trying to think what else we have coming up. I mean, I'm pretty sure we'll be in New York City Maker Faire.
Oh, yeah, come visit us there. We'll have some cool stuff.
Yeah, we'll probably do a raffle. For
Demo some kits.
Yeah.
Might see some upcoming kits there.
Wow. And I should probably look up when that is. I think it's in either September or October. I'm sure there'll be a Facebook announcement or on the forum once we know exactly where we'll be. So that's pretty cool. I like Maker Fairs. Probably go to more of those. We were at the Buffalo Maker Faire 2 months ago, a month ago, whenever that was.
Alright, new strategy. Just kidding.
Would you like some help?
Man.
So I see you've broken out the solder wick.
Yeah, I'm getting desperate now.
But not desperate enough to call me in for help.
Give me 1 or 2 more minutes to see if I can get the negative leg in.
Minutes?
Well, figure of speech, but yeah, probably minutes.
So Spencer has successfully soldered the solder wick to the... Oh, no, I got it off.
Okay, so we've got our capacitor legs here.
So Spencer.
Yeah.
Why did you design this kit? How'd you get the idea for this kit?
So I designed the Wi-Fi light switch kit because, well, so have you guys ever had, when you go to bed, you get in bed and you're all like wrapped up in the blanket and you're all wrapped up in your blanket and you find the perfect position in your bed and you're just comfortable and everything, and then you look up and you see that you left the lights on and you have to get back out of bed, go across the room, touch the cold floor, turn the lights off, and then get back in bed.
The cold floor that's filled with upturned headers, plugs, and Legos.
Yeah. So I was sick of doing that. So I said, why not design something that allows me to, from my bed, turn the lights on and off? And the Wi-Fi light switch kit was born.
Wow.
I have to say, it's quite nice.
It's quite nice. I like it because you don't have to mess with the wiring in your house.
That's another good point, yeah. So the entire Wi-Fi light switch kit installs over top of your standard light switch, and you don't have to remove anything except the 2 little screws on either side. You don't have to remove the light switch plate. You don't have to expose any of the wiring.
You don't have to turn off your fuse or mess with any kind of power stuff. That's why I like it. That's why I think it's pretty clever. But don't tell Spencer that. Okay, Spencer?
I'll keep it a secret.
Okay, thanks.
Man, this negative leg is just really being negative.
I'm going to count that one for me. You know, I never got a smoothie yesterday.
Oh, that's true.
I might get one today.
I can't get it in the next couple seconds. I'm going to give David a shot, and
then we're going to call Liz to get us a new kit.
Or I was going to try some
magic.
Yeah.
So now's a good time for questions.
You guys want to know any Thimble trivia, or what it's like to work here, or how we design our kits, come up with the ideas for them. What the next kit is, just kidding, we can't tell you that one.
It's locked in the vault. Alright, Spencer. I'm calling it.
Here we go. Let's try this.
Well, he's got the capacitor out of the board.
Okay.
I think I see where you're going with this. So yeah, when we design kits, I mean, we try to hit a balance of like practicality and fun. So I think the compass is a good example of that. You know, it's cool because it lights up, unlike a normal compass or the compass on your phone. But it's practical because it's a compass. Same thing, I would say to a degree, with the Wi-Fi robot.
Oh, that's just fun.
Yeah, that's just fun for you. I think the cube is all fun.
All right.
You got it?
It's in.
Yay!
It's not perfect, but as long as it's soldered in, we're all set.
All right, so we can go back to our instructions.
Hopefully you guys have enjoyed your snack and a little break. Got everything all set. David's made pretty good progress in peeling off that paper, which will be helpful later on.
Yeah.
So we've only got 3 pieces left. One of them is the ESP socket here. This is the 4-pin by 2-pin rectangular socket. If you want to make the solder one big again. So this goes up here in the top left, right next to the capacitor. And that just goes in like that there.
Can I put it in the other way?
Yep, it's just a... Oh.
So welcome to Thimble After Hours in the Dark.
The motion-activated lights turned off. Hold on a second. Don't recommend soldering at nighttime.
I highly unrecommend it.
There we go. Hold on a second.
No, it's fine.
There. Okay. If you ever wanted to see what the Wi-Fi light switch kit could do telepathically, it's that.
Retroactively, it turned off the lights.
Yeah.
That's a good kit.
Go ahead and solder the ESP socket here.
And again, like everything that we've been putting together, individual solder joints, not just one giant blob across pins. Okay.
I find that putting a soldering iron on the outside makes it easier to keep your solder joints separate. Right. So that was relatively easy. We've got our ESP socket, and then the only thing left to do is the ESP breakout header, and that's this guy here. The ESP8266, the Wi-Fi module that we're using, has some extra pins and functions that aren't used in the Wi-Fi light switch kit that we figured we'd break out so you guys could mess around with them and add your own stuff later on. So we added this little header. It's optional to solder it in, but I'm going to do it now because I'm going to do some stuff with this later on. So we'll put that here in the top right. Now these headers don't hold themselves in because the pins on the bottom are too small for the solder to work correctly there. So just put this in here like that.
So you said you're going to do some extra stuff with this later. What are you going to do?
So the ESP has 2 extra data pins and some other chip functions. So I was thinking about adding maybe a daylight sensor so that I could put it in the window of my room and turn off the lights when it gets sunny outside and then turn them on when it gets dark.
Cool.
And that's, you can use the 2 GPIO pins here for that.
I suppose you could also add a small microphone and make a clapper.
Yeah, you could do that. Everybody wants a clapper. All right, so the very last thing we need to do for our electrical assembly, now that we've got everything soldered in and our capacitor is fixed, is our ESP is going to be plugged into the socket here in the top left. And so there's the 8 pins here of the ESP. They're going to go into the socket lined up like so. The ESP is going to face up on your PCB. And now we're all set with the electrical assembly of the Wi-Fi light switch kit.
Good job, Spencer.
So we're not going to turn off our soldering iron just quite yet. We're going to grab an Arduino here and double check that everything's working and see if we need to make any more corrections to our soldering to get everything working. So I've got one of our Thimble Arduinos here. I'm going to leave it unplugged for a second. So the way this attaches to your light switch kit is you're going to use this row of headers here with the analog in and power markings. You're going to line those up with your light switch kit headers here. So you'll notice that the 8-pin and 6-pin headers, male headers, line up with the female headers on your Arduino like so. So there's the 8, and then there's a little gap, and then the 6. And those just click right in like that. And that will be just like that. So now we'll grab our power connector for our Arduino.
Well, I think you also might need this.
Oh yeah, and the servo.
So, in the bag that's included in your box, you have this little blue box, and this is a little micro servo, and it comes with this cable, and oh, you probably can't see that at all. It comes with this little servo and this little bag with a couple of accessories. So we're going to take that out. I'm going to hand it to Spencer. I've handed it to Spencer.
If you don't have a Spencer, those are optional.
You can go on parts.thimble.io.
So for the servo, there are 3 wires coming off of the connector, a brown one, a red one, and an orange one, or some people call it yellow. But the way this goes in, you're going to put the brown wire, which is the ground connection, here on the right, where it's labeled GND on your Servo 1 header.
What does that stand for?
GND is what abbreviates to ground,
Wow.
which is what's on most PCBs. You can see here on the Arduino there's GND also next to the 5-volt rail.
Okay, so we're going to plug that in.
We're going to plug in with the brown wire facing to the right
And what's supposed to happen?
in the Servo 1 header. So once you've got the servo plugged in and your ESP plugged in, your Arduino connected, plugged in but not powered, once you attach the power, you should hear the servo like start and move to its home position, I guess you'd call it. And then you should also notice there's 2 little LEDs on your ESP, and those should light up. And that will let you know that your ESP is powered correctly and that your servo and everything else is connected properly on your PCB. So we'll go ahead and we'll plug in, and we'll listen for the servo to make a little noise, and we'll check that the ESP is lit up. So you might not have been able to hear that, but the servo moved just
Yes.
a tiny little bit.
I can agree.
David's
yes.
my second set of ears. And then you'll see that there's a red light here on your ESP, and you can actually unplug and plug it in again. You can see that it flashes a blue light and then the red light. And that means you're all set with the soldering. So that means you've correctly soldered in all your capacitors, your MOSFETs, your voltage regulator, your diodes and everything. If you notice that your ESP doesn't turn on, then go ahead and triple check that your diode is soldered in correctly. If you put that in backwards, then it'll block the flow of electricity to your ESP, because that's how diodes work. They allow electricity to go one direction but not the other, which
Okay.
is why it's very important to get it in the correct way.
So, I'm going to start handing you extra things. We're going to start the mechanical assembly.
Right. So there's a tiny little bit of code we need to run from the Arduino IDE to get our servo correctly calibrated. So if you go to the learning website like so. And now that you're finished with the electrical assembly, you'll be here on the mechanical page. And here under step 1, the controlling the servo step has 14 lines of code that you can just copy and paste right into your Arduino IDE. Like so. So you'll see that you've got your servo include, which includes the servo library, some other servo stuff, and this is what it's going to do, is it's going to try and tell your servo to move from 0 to 180 degrees, and that's going to check the range of motion of your servo. And this is another check that you can do to make sure that everything's working correctly. So once we've got our COM port selected and our Arduino Uno selected, and we've double checked that it's plugged in here, so it's going to be COM5 for our Arduino. So here you go, you can hear our servo moving.
I can hear it. You should be able to hear that.
I'm going to quickly put a little horn on just so you guys can see it move. So here in the big view, you can see that the servo is rotating from 0 to 180, so it's flipping this upside down like that. So now that we know that our servo is working correctly, we can change the code here so that the servo writes to 85 degrees, I think is what it says. Let's see what the module says. Yep. So we're going to change the Thimble servo write command to say, instead of 0 degrees, we're going to make it say 85, and then we're going to just delete the other Thimble servo write command so that our loop looks like this. We'll go ahead and upload that, and then you can see our servo should stop moving. And if I hit reset our Arduino here, your servo will now be calibrated to the 85-degree mark, which is the center point and the middle position for the rest of the mechanical assembly.
Okay.
So now that's all set.
So we know it works. Our ESP turns on, our servo turns on, we can hear it. Let's go. Next step.
So we don't need our Arduino plugged in anymore, so we'll go ahead and remove that for now. And now we can move on to the mechanical assembly. So we're going to do it for the toggle style light switch because that's what we have here in the studio. So we're going to click on the...
Gotta put the servo in first.
Right. So we've got our instructions pulled up on the Thimble learning module for the servo assembly. So we're going to take our servo here. I'm going to undo the Arduino for this next step, so we won't need that for now. So we've got our servo here. And we're going to grab the 2 screws from our parts bag. So just dump this out so you guys can see. Line up these screws here.
Okay.
So these are the parts you should have for your mechanical assembly steps. I've moved them all off the camera. Perfect. Gonna slide that down so you guys can see. So these are all the screws that you should have. So for the servo assembly, we're going to be using the smaller M2 screws. So these are these little guys here. And then we'll use 2 of these smaller nuts as well. So go ahead and move this back.
Okay, so put the servo in.
So the way you're going to line up the servo, you're going to take the cord here. It's going to be facing down on your PCB. So you'll just put it right through this hole, like so, and it should fit snugly. Now you've got these 2 holes on the top and bottom, and that's where these little screws are going to go through. So you'll put one through the top here. I'm going to put the nut on right now, just finger tight for the next couple seconds. So So I'm going to take the bottom one, and that's going to go right through the bottom hole here. Whoops. And we'll grab our nut, put that on.
Now this servo is what actually flicks the light switch on and off.
Yep, so this is the servo that does all of the controlling of your actual lights. So I'm going to grab my screwdriver here. I'm just going to tighten these, and I'm going to put my finger on the nut on the back. You can also use a pair of pliers to carefully hold the nut, but I found that just using my finger to push against it is fine.
And he designed it.
We want to make sure these screws are nice and tight because we don't want the servo going anywhere while it's moving. Got those all tightened down. And I'm just going to take the cord, and it's wrapped really nicely. I figured out a good way to wrap it. You can look at the pictures on the learning module and show you how to wrap the servo cable so that it's nice and tight to the servo and doesn't get in the way. But I'm just going to do it quickly like this. I think the tape is over there somewhere. It might have fallen down. We're going to plug it back in with the brown wire on the right side here.
While I go look for tape.
David's going to grab me a piece of tape. All right. Yep.
If you don't have a David, you can check out parts.thimble.io.
Use this little piece of tape right there, and that's going to hold our servo cable in place like that.
Nice. Looks just like the picture. Okay. If you're following along with the learning module instructions, we already did controlling the servo, and we did set it to 85. So now we can do this.
The servo horn step, which is going to set the PCB aside for now. We're going to grab the actuator plate here.
You know, it just occurred to me, maybe I should have left the cardboard on.
Hopefully you guys can see this.
That's worse.
That's worse. Hopefully you guys can see this. The actuator plate is the big rectangular plate with all the holes cut in it. And that's going to be the base of the mechanical assembly. So we're going to really build off of that along with the PCB.
Okay, so what do I got to do?
So I'm setting the actuator plate down on the table with a little hole here in the top right. And then I'm going to grab from the servo bag one of the pointy screws. And these are the ones that have a little ridge on them. I don't know if you guys can see that very well. Doesn't really matter. But you're going to grab one of the pointy screws from your servo bag, and you're going to put that up through the little slot here in the actuator plate so that the screw is sticking, the screw part is pointing up when it's sitting on the table. And then also from your servo header, or your servo bag, you're going to grab the 90-degree servo arm. That looks like this. So what we're going to do is we're going to screw that screw we just put in. We're going to line it up with the very last hole on this arm. And when we're going to have this pointing up. So we'll set it down like that on the last screw. This might be a little tricky.
But you only have to do it once.
You only have to do it once. Alright, so you can see I've just started the screw here. So we've got our hole in the top right. We've got our screw through, and the servo header is facing up. So I'm going to go ahead and tighten that most of the way. But you still want to be able to let the arm swing loosely, so you don't want to tighten the screw all the way. Alright, now that that's done, we're going to go ahead and click on the toggle style light switch instructions, and those are going to bring us to the correct set on the page, and then we're going to follow from there. So now that we're done with that, we're going to take the two long screws here.
Big boys.
We're going to put those through these two big holes on the PCB like so. And they might be a little hard to get through, so you're just going to have to twist them with your hand a little bit to get the screw started and go all the way through the PCB. So I'm just going to do that. Get this one all the way down through, just like that, so the head of the screw is flat, and we've got it poking through the back. And I will do the second screw here in the top. Being careful not to break the ESP or the capacitor from earlier.
We only have one more spare. So are we done soldering?
We are all done soldering for now that our PCB is all working, so you can go ahead and shut off your soldering iron and leave it somewhere safe to cool, and then put it away when you're done.
Yeah, because even though we haven't used it in a couple of minutes, it's still going to be pretty hot.
Alright, so I've got our 2 screws through. We're going to take our set of small spacers, so these are the little ones, little circles here, and we're going to take 3 of those. We're going to put those on the bottom screw like this. So 1, 2, and 3. We're going to push those all the way down so that they're touching the PCB. Then we're going to add a large spacer, and then we've got our washer here. That's this little metal disc. We're going to put that on the screw. That's going to slide all the way down. And we're going to add a second, well, this is now the 4th small spacer. And now, this is a little tricky, you're going to take your actuator plate, and with the servo arm facing the PCB, we're going to line it up right like this with the small spacer in this round hole. And then to finish this off, we're going to add the other 2 large spacers. And now we're all set, so I'm going to use a piece of tape, just wrap it around the screw here so that these spacers don't come off in the next couple steps. So you can see on the screen here what that should look like. And then we should now have 6 small spacers left over. We're going to put 5 of those onto the top screw here. So it's 1, 2, 3, 4, and 5. No, I lied. It's going to be 6. Yeah, 6 small spacers here on the top screw, and then
he designed it.
Your large spacer. It's hard to keep the assembly sets in my head separate. So you should now have all of your spacers put on your light switch. You shouldn't have any more spacers left over on your table. The only 2 pieces you should have left are this extension piece, which we're not going to use for this assembly, and the force mountain piece here, which we're also not going to use for this assembly. These are for the paddle style light switch. So if you're following along for those instructions, it's almost the same set as this, but a little bit different. I'm not really sure how to phrase that.
Okay, so we've got the 2 long screws all spacered up, and they have tape to keep them from falling off of stuff. So,
yep, just add a second set of tape right here. So now our mechanical assembly is all set for that. You should also have a couple extra pieces, screws and things. Those are going to be left over from your other mechanical assembly set. So those are going to be everything else that we haven't used already.
When do you put on the servo horn?
The servo horn gets attached to the servo when we put it on the wall. So we're going to leave this loose right now, and then when we go to put it on the light switch, we are going to attach that servo horn to the actual servo.
Okay.
That way we can have everything lined up. So, if you're doing it for the toggle style light switch, you're all set with the mechanical assembly. And now that you're done soldering and everything, you can move on to the code section. So we're just going to quickly walk through the code here. On the learning module, I've created a video that shows you how to install the ESP library for your Arduino IDE and get your Arduino all selected and set up. So go ahead and watch that video. It's quite nice. But we've already got the ESP library set up, fairly certain.
We can actually check by going into Sketch, include library, and do we have it?
I'm not quite sure. Well, let's do a quick demo of that. So you can just download the ESP library zip file, and then that'll be in your downloads folder. No, you don't have to do that.
I don't have to do that?
So you can go right from Arduino, from the include library section, and then add zip library. And then because it's in our downloads folder, we can just go right to there and select the Wi-Fi ESP library zip. Now you should see this message here in your IDE. And that means you've correctly installed the library. And to double check, you can just go to the examples, and at the very bottom you should see your Wi-Fi ESP examples. So now that that's all correct, we'll switch back to our code section now. So the first thing we're going to add are the include statements, and these tell the Arduino IDE what libraries we're using. So you can see we've got the software serial, the servo library, the Wi-Fi ESP, and then the ESP UDP library, which is what allows us to send the packets of information to your ESP that tells it how to turn your lights on and off.
So where am I supposed to put it? Am I supposed to put it
here? Nope.
Am I supposed to put it here?
Libraries go at the very top of your Arduino sketch before everything, and they
How's that?
Go just like that. It's perfect. Yep. Now we're going to add the Wi-Fi information, and this also goes up there. Yep. So this is you're gonna have to change this, obviously, because hopefully your home wireless is not called your Wi-Fi name and your password is not your Wi-Fi password.
So I'm gonna do these off camera later.
We'll do this later, yeah. But in the example, it's got, Thimble HQ and I love Thimble as the password. So you'll set that to whatever your home Wi-Fi password is, so that your ESP can connect to your wireless network at home. So those both go up above the setup. And then the other thing we're going to add is the serial communication that will set up the serial to use the A2 and A3 pins on your Arduino, and that'll go right below your Wi-Fi password information right there.
Okay.
So now that we're done for now with everything we're going to put in the header of our sketch, it's time to set up the serial communication, and this will go in the setup function, which runs only once. Only when your Arduino first turns on, it runs through this code and then continues on to the loop, which it runs continuously. So the serial setup is going to tell the Arduino what the baud rate is, how fast it's going to communicate, and then it's also going to set up communications with our ESP. So I'm going to have our Arduino plugged in. We should now be able to upload this code to our Arduino just to double check that everything's working. We'll go ahead and save this sketch so we can continue. Select our Arduino again.
Or do I?
Perfect. So now we can double check. We can open the serial monitor by clicking the button here in the top right. And now you should see that we're initializing. Oh, one step you may have to do depending on your IDE is the baud rate here in the bottom left, or bottom right, excuse me. You're going to change it to 115200, and this matches the baud rate we set in the code. So if you're seeing weird characters and stuff popping up, make sure you've double-checked the baud rates. Yeah, so if you see this sort of thing, you've got to change your baud rate to the 115200 set. And now you should see the initializing ESP module set up here and that information. We're going to have to change the... So if you see this message, the timeout and everything, that's because you probably have the wrong Wi-Fi information. So we're going to go ahead and put that in and do that.
I don't know how to obscure the password.
You can just flip back to the main camera. Can you do that?
Okay, I did it.
If you come visit us, we'll let you on the Wi-Fi. You can just cover it with the serial monitor, I guess. So. All right, one last thing. Make sure your Arduino is plugged into your Wi-Fi light switch PCB. So I'm going to flip that over like that. I don't know if you guys can see. We're showing them which screen. So we've got our Arduino plugged into our light switch kit, and our ESP is powered on and everything. So now when we upload our code and run it, you should see that the initialization was successful and that you've connected your ESP to the wireless.
Yay!
Or connected to your ESP. We haven't quite connected to the wireless yet because we haven't put that in our code. But so now you should see the connection successful, and that means your Arduino's detected your ESP. So we're going to go up here to the top, and
I think we got to wrap up.
Yeah.
We have been going for quite some time.
We'll connect to... Also, you want to just quickly run through the rest of this and be done?
That's really quick.
Oh, yeah. Well, we've got another, what, half hour-ish, I think?
Yeah, we've already been going for an hour and a half.
I think we should keep going real quick and see. If you guys welcome to stay with us and continue through the rest of the code. We're going to go through it a little quickly, but all the code and comments are on the Thimble Learning website, as well as we've got the forms. You can ask questions, and then if you're really stuck, there is a completed code written at the end of the module you can download. So let's go ahead. I think we're going to go ahead and download that and just run through the comments really quickly. If you go to the further reading section of the Wi-Fi light switch kit, there's a completed Arduino sketch that I wrote and uploaded. It's at the very bottom. Almost at the bottom. A little bit higher. Oh no, sorry, it's in the troubleshooting section.
He designed this.
Right? Yeah. So in the troubleshooting, under the code troubleshooting, you can see right here, if you're really stuck and can't get your code to work, download the Wi-Fi light switch code, and that will give us the entire set here. So we'll just quickly run through that. So this is all of our code for the light switch kit. So we've got our Wi-Fi information set up, we've got our servo, we've got our button pin correctly wired or initialized. This is one of the things you have to do is look at the schematic on the website and see which pin the big button is set to, and then you can put that information into your code. So this is the schematic for the Wi-Fi light switch kit, so you can follow over and see in the blue text there on the left that the button is connected to pin A4 on the Arduino. So, moving on down through there, we've got our UDP port, which is how we tell the ESP what connection it's going to use, basically. So that's the UDP port number. You can read a little bit more about that on the learning module in the further reading section. We've got our button Boolean variables and servo up and down variables. So those positions you see there on the left, the center, up and down, you can change those numbers a little bit, make them bigger or smaller depending on your light switch in your own house. So that lets you fine-tune the up and down connections of your servo. Now we've got our packet buffer size and things like that. That's for the messages for your ESP. Further on down, we've got our Wi-Fi information. That's just for the ESP, so that tells it how to connect to your Wi-Fi network. It sends you a message, gives you all the information about your connection. That's useful for debugging and also making sure that everything's correctly connected and set up. Further through there, we've got our button information, packet information. This helps the Arduino and everything with its connection.
That's a lot of packet information.
Yeah, I tried to make that as small as I could, but UDP packets are a little complicated, so I didn't make you guys write all that part from scratch. You can just go ahead and copy that right from the module.
What a nice guy.
That's all set up correctly. And then the only thing left are the functions. So we've written one that's the print Wi-Fi status, and this gives you some debugging information about the signal strength and your IP address of your Wi-Fi. So that helps you debug whether or not you're connected properly and gives you information about that. And then underneath that is the button case function, which this is what controls the servo when you push the big button on your PCB. So it's a case function which has 3 cases. So depending on when you push the button, it'll either enter case 1 to turn the lights on, case 2 turns the lights off, and then case 0 is just the resting case when there's no button pushed and the servo isn't doing anything.
Wait.
It's called, also known as wait. Yeah.
Wait. Wait.
Yeah, it just waits there forever until you push the button.
Wait.
So that's a quick overview of the code for the Wi-Fi light switch kit. If you guys need a little bit of help with that, feel free to go ahead and there's a forum thread on the discussion page so you guys can talk about the code. Please go ahead and share like other code you guys have written. So if you've written something that uses a light sensor like I mentioned, or if you guys make a clapper, go ahead and share the code. Share the code for the clapper so we can install those all over the Thimble office. That'd be pretty great. And any other questions or comments you guys have, feel free to let us know. Aside from that, thank you guys for watching the assembly of our Wi-Fi light switch kit. Have a great rest of your Saturday, I guess, yeah?
And weekend.
Weekend. Cool.
Okay.
All right. Bye.